Good evening, everyone. I welcome you all to this second lecture in the Unit 4 E-line theory. So, the outline of the presentation, assumptions in the E-line theory, sign convention for E-line pattern and supports, the guidelines for the E-line patterns. Then, at last, we are going to practice few example uh, problems on this. Few uh, examples like how to draw the E-line pattern for different geometry and supporting conditions. So here in the assumption of the E-line analysis, the first assumption says the reinforcement that is yielded along the E-line that is formed during the collapsed stage. And the second assumption says the slab is divided into different segments when it reaches or when it collapsed completely. So the slab is divided into different segments with the E line. So these E lines are dividing the single slab into a divider segments. And then next, so here we are considering the third assumption says the elastic deformations are neglected here. We are considering the plastic deformations. And again, in the second assumption itself, we have seen that individual segments are of the slab again it behaves elastically. So only this fracture or this along this E line only it behaves plastically. So we are the entire deformations therefore take place only along the E lines. Okay, so these individual slab segments remain plain even in the collapsed. So then comes your fourth assumption. So the bending and the twisting moment which will be distributed uniformly along this yield line. Okay, the moment will be distributed uniformly along the yield line. So that is your fourth assumption. Then so the moment value is completely depends upon the reinforcement, the amount of reinforcement that we have given for the slab. And then next, the E lines are straight lines. So you can see these E lines are straight lines. It is not going zigzag way. Then, so this as they are lines of intersection, I mean these are the line of intersection. So it behaves like a straight line. Then next, the last assumption here is the effect of shear or bond or deflection is completely neglected here in the yield line. So only you are considering the moment. So here we are going to see the sign convention used for E-line pattern. So we have designated or standard sign convention. So we can also maybe the standard sign convention. So this will be like a fixed one. Okay. So the first one is free or unsupported edge. If you have a free or unsupported, we have to represent that with a straight line, the plane line. Then simply supported edge then means we have to use this symbol. For fixed and continuous edge, we have this symbol. And for positive yield line, so the positive yield line generally occurs at the center of the slab segment. The negative yield line occurs at the support. And then axis of rotation, again the negative yield line act as axis of rotation maybe anytime. So then beam support is denoted with the help of double line. Then the column is with a rectangular box, in the hatched box or a solid rectangular symbol. Then a point load is with a round symbol. So next we will see the guidelines for E-line patterns to draw E-line pattern. The first guideline is, so the fractured segment is rotate about a certain axis. So which often we refer it as the line of support. We often, so this line of support, maybe this line of support may be beam, that we can have a beam here. So that is the slab is reported on the beam, or your wall, okay, where the slab is supported, or sometimes we even the line that is passing through a column. So example, we have a column here, you have the column here. So in case of flat slab, we don't have a beam. So in that case, so the line that is passing through a columns, okay, so that is often we consider it as a rotation axis. Okay, then the E line separating as two slab segments. We have one slab segment here and another slab segment here. So the E line that is separating two slab segment generally pass through the point of intersection of two axes of rotation. So yeah, this is one axis of rotation, this is another axis of rotation. So this E line which divides two slab segment will pass through intersection of these two axes of rotation. So this all fractured segments again it assumed to be planar. And then next, the positive yield line is forms at the interior region of the slab, not at the exterior. So generally positive yield line forms in the positive moment, that is in the fogging. So that is the positive yield line form in the interior region of the slab, and it terminate, the positive yield line terminate at the boundaries. You can see it's not extending after the boundary, so it ends in the boundary, slab boundaries. Next, the negative yield line forms along the line of continuous or fixed support. So the negative yield lines are at the supports or the boundaries. So this is your negative yield line. So the yield line should end at the boundary. Actually, this yield line should end at the boundary of the slab line, or so after that it won't extend. Otherwise, this another, when it meets another yield line, so there it has to end. So then the yield line is representing the axis of rotation. Yield lines will occur under point loads. Okay, generally this yield line occurs at the point load. So example, if you have a point load here in the, say example, this is your circular slab, you have the point load, and if you have a point load, so it start in the under the point load, and it will radiate outward, and it in this yield lines will end at the boundary. So that is what your last guideline. So here you can see here for a different geometry we have a different pattern of yield lines. So for a square slab, so we have this. So what are the guidelines we have seen so far? So with the help of those guidelines, we have to draw the yield line patterns for a different geometry, for a different supporting edge. So this one is square slab with the simply supported edges. So you can see the simply supported, to represent the simply supported edge, we have the straight line, and on that we have the cross lines. Then we have the square slab, and so for the same square slab, for a different supporting additions, for here it is a simply supported, but here it is a fixed support. So fixed support or continuous support. For a fixed support or continuous support, we have additional, we have negative yield line. So we have, in this case we have only the positive yield line, but here we have only the so we have positive yield line at the center as well as the negative yield line at the boundaries, and here remaining all other supporting conditions are simply supported. So here you can see here, so this is your simply supported slab, so where you have only the positive yield lines. So we don't have a negative yield line. So also there is no rotation resistance or rotational resistance in the at the supports. So this is the practical view of this slab that is tested in the lab. So where you can see this, so these are the yield lines. Okay, these cracks of the yield lines. So this is simply supported case. So generally it appears in the bottom of the slab generally. Okay, and you can see these are positive yield lines. So this is in the case of simply supported. So you can see the hatching. So this represents your simply supported condition. So here for this continuous or fixed slab supporting condition, so we have this yield line. So that is, we have the positive yield line at the center, at the negative yield line at the support, and so these are the positive yield lines. So the positive yield line generally you can observe at the bottom of the slab. Okay, so you can see this positive yield lines, and it ends at the boundary. And next you have the negative yield lines that forms at the support or at the edges at the boundaries. So that forms in the top. Okay, being at the negative yield line, so it forms at the top of the slab. So this is a practical test. These are the slabs tested for yield lines in the lab. Next, so here the slab which is supported on edges on two sides and with one column. So here the support is simply supported. Now if you look at this E-line pattern here, how to draw the E-line pattern for this. So what we'll do is, first step you have to do is, if you have a column, then you have to draw a line, okay, which is connecting the column, and you have to extend that line on either side. Okay, and then next this extension of the line, the column line will meet the other two support lines. Okay, so that it intersects at some point. Okay, and then next These, as per the guideline we have seen, so these yield lines will pass through intersection of two axes of rotation. This is one axis of rotation, this is another axis of rotation. So this yield line, we have to draw a yield line such a way that this will pass through the intersection. The same way here one intersection, one axis of rotation, this is another axis of rotation. So this we have to draw one yield line which can intersect with the this point. And as we know, this yield line will stop at the boundary of the slab, it will not extend further. Then here also, so here we have one axis of rotation, this is another axis of rotation. Thus now the yield line will pass through intersection of two axes of rotation. So again this also stops here because it is a boundary of your slab. So this way we can draw a number of yield lines in the number of yield line patterns for the different geometry, for different shapes. And this is again this is also simply support the same case what we have discussed there, the same problem. Here we have a circular slab which is supported on columns, not there is no support on the edges, only it's supported on the columns. So what we do is we'll draw the straight lines for 4 columns. For all the columns, all sides of the column, we are drawing a straight line, the line of support, and it intersects, okay, at some point with another the line of support. So here this yield line will pass through the intersection of two axes of rotation. So this yield line will pass through these two axes of rotation. This yield line will pass through two axes of rotation. So also it ends in the boundary. Okay, it won't extend further. So this is how we have to draw the. So for this type of supporting condition, that is supported on 3 sides, free at one end, we can draw yield line in whether this way, or even we can draw even this way also. So either way of doing is correct. So hope you all can draw yield line pattern for a different geometry for different supporting condition. So you can try out many problems, so you can so that you can understand this concept better. Thank you.